All right, let's try that again. Good afternoon, good evening, and good morning, everybody. Welcome back into the Dragon's Den. As you can see, we're coming with the side angle view here uh, because we've got this beast of a machine still up on the bench. Beast is the RatRig B-Core 4. And I finally remembered that I had a RatRig shirt that I got from Rocky Mountain Rep Rat Fest. So I had to go find it where I had stashed it so I could wear it on stream. Yeah, I figured I forgot I had the audio muted. I'm still working on things with the new Stream Deck because it mutes the mic at the computer level, not at the OBS level. So yeah, I, I'm getting with it. Well, welcome on in, everybody. Tin Talon, Mr. Wizix, Nick, Royal Nomi, Timor, welcome on in, gang. Welcome on in. Uh, yeah, I was thrown off with a little bit of last minute shenanigans, like forgetting that I was going to pop the X rail off and um, grease it because we did not grease this particular rail. So I did pop that off, re-grease it, get it back on there, and then started getting things out for today. Um, so yeah, welcome on in, everybody. Thanks for being here. I'm going to go ahead and switch the camera view real fast. We're going to go to the overhead camera real fast. And you'll kind of get a little bit of a glimpse of, well, thought you were going to get a glimpse of what we had in store for today. Let me see if I can extend this out anymore. Just a little bit more. There we go. So I had to go in and grease this rail. So I had to take it off real fast, grease the bearings in this carriage, and then I got it back on before the stream started. And today we're going to be dealing with all of this. And we've got a Orbiter V2 here. It's got a short wire and then a long extension wire. We probably won't need this because we're going to be using this and a EBB 42 CAN bus board that we're not, from what I can tell, we're not going to be doing CAN bus on this. We're actually going to be doing just USB. So we're going to be doing a straight clipper install on this and talking to it over USB. And then we're going to have our Fadus 2 hot end. Now this is a standard Fadus 2 ultra high flow. It's not one of the new fiber ones, which would have the steel nozzles, the hardened steel nozzles and the hardened heat break on it. I'm running one of these in my Annex Engineering K3 with a steel nozzle and a non-hardened heat break, and I've run 3 kilograms plus of polycarbonate carbon fiber through it, so I'm not that worried about needing the hardened heat break. Just throwing a hardened nozzle on here will be good enough. And then we've got all the parts here. And I was thinking, do I take the printer down and we build the tool head? And then I started looking through the instructions, and the first several pieces of the instructions, I pop over here to browser view, which has me back to this camera as the default. And obviously the small app is not set up on the right view, so that's set up. There we go. On the first set of instructions here, it's go put all the heat set inserts in. Well, if I go to do that, all the heat set inserts are already installed. So no need to do the heat set inserts. So the first, I don't know, 11 or so things here, steps here, are all about doing heat set inserts and fixing some parts which are already done. And then step 7 is to actually get the stuff ready for the tool plate. And we've got a whole bag here of parts, which includes the tool plate, some standoffs, some tools, or some specific items that'll get used in this build or in the toolhead portion of the build, to include the entire packet of heatset inserts that I would need to install had they not already installed them. So long story short, there's a lot of heatset inserts in this kit that you don't need to use if you go with the standard parts. Now, if you wanted to change up the color scheme, which I didn't want to do, you're free to print all the parts, and then you'd have to go through and do all the heatset inserts. And I would say, yeah, for once, I'm building a printer that I did not have to go and do a bunch of parts for. So we've got our plate, and we're going to have 4 small, what are these, M3 by 6 countersunk screws with applied thread locker. So it's the M3 by 6 BT, so blue thread locker already applied. So we found those things. So yeah, the overview, by the way, from the last stream, we finished off the Z-axes, and that included installing our Z-motor like restraints or constraints with bearings at the top of each of the 3 Z-motors. Or the Z's. We added the bed plates. We built these out and installed these. Then we added the constraints. We installed our motors, and once again, we've got our standard 4XY motors at the bottom, and we've got a second set of motors at the top. This is the hybrid motor package. So this is the first, we'll say, factory upgrade, is installing these, and this will be a separate belt path that comes across the top, and these are just to help do additional additional motors in the y-axis only, because moving the y-axis, you're also doing the entire X carriage and tool head, where the X motors, when you're doing an X motion, you're just moving the tool head. This is why we're beefing up the Y. And then also, I'll say the next step in the evolution, it's not available just yet, would be the IDEX upgrade. What we'd have to do there is remove the belts from the XY path. We would take the tool head off, really. And when I say take the tool head off, undo our rail, pick it off, add our second carriage on, get the rail back on there, and we'll change the belt path some, but we would be able to have IDEX and 2 independent tool heads. So that's going to be a down the way thing once it becomes available. So now what we're up to doing, it did suggest running the belts already. I'm not going to run the belts yet because I don't have a carriage to tie the belts into. So as soon as it tells us to tie the belts into the tool head as we're building it up, then we'll go ahead and run our XY belts. The straight Y belts themselves will get run at a later time. You got your first order of Fibron. Awesome, Nick. Technically, I've already been using the Fibron line. It's just called in fact, I've got 2 or 3 spools of let me find it. Actually, more than 3. I think I've got 3 or 4 spools now. But this is one of the Fibron line right here. It's the Polymaker PA612CF. All right, give me 1 second. All right, maybe that'll help if I get my lights up a little bit more. This is the polyamide PA612 carbon fiber. This has been moved into the Fibron line. And yeah, this stuff prints beautifully. And I've gone ahead and I've got a bunch of the Polymax PC and the Polyamide Co PA as well that I will be using for various other things. And I did go ahead and ordered a couple of parts. Zombie will probably know what these are. Hey, Chris, too, how's it going? Welcome on in. So this is a mini heater. This is, what is it, the WYH1. It is a, what do they call them? Not a PWM. I don't know, it's a 110 volt heater with a Inkbird, which includes a temperature probe. So what we can do is we're going to set this up in one of the carbon, the X1 carbons, and this will become a chamber heater for that, a PTC heater. There you go. And then I'm going to have a different type solution that I'm going to do in one of my borons. And that's going to give me the ability to have a couple of printers with controllable chamber heaters. And so that way we'll be able to that back on, turn that off. That way we'll be able to run some of our polycarbonate and stuff like that a lot easier. But I can't remember what I did with that one part that I was taking to a coworker, but it came out really nice, even without a chamber. Okay, so we're gonna mount the RatRig plate here, or RatRig, the Toolhead plate, and this is a nice piece of anodized aluminum, I believe. I don't think it's steel. Let's see. Yeah, that's aluminum. There is a lot of steel on here, but these are anodized aluminum plates. And this is going to mount right here with the 4 M3 screws. The big fan goes in the back side. We're going to use these M3x6 screws that have Loctite already on them, which is nice. Thanks for the lurk, Zombie. Yeah, the PTC heaters. And what I normally do here is I start to get these put in, but I get all 4 of them in, and then I'll start to tighten them down little by little. And it's just using the countersinks to basically like center the plate appropriately on our carriage. And these have Loctite already on the screws, so there's pre-Loctite on them, and because of that, it's going to stay in there. We don't need to really crank down and torque these down. In fact, if you do, you stand the chance of binding the ball bearings inside the linear rail, inside the raceway for the bearings. So you want to, tighten them down, finger tight, and then maybe, an 1/8 of a turn past that. You want to make sure that nothing's binding and you still have good movement on that carriage. So we got those down, and once again, it's showing I'll say the pointier tip towards the front and the fan towards the back. And yeah, want to say I need to still work on that camera because I think I need to flip it 180, but I'm not going to do that with you guys on here just yet. Now it's going to tell us to prepare the back duct assembly, which is basically start getting a bunch of screws and everything laid out. We're going to have a fan. What did I do with the fan? Oh, over here. We're going to have a big fan, and this is a big fan. This is a 40-28. So it's a 40 by 40 with a 28 millimeter depth to it. So a lot different than what we're used to with maybe a 3010 or a 4010 fan. So this is considered an ultra flow. It is a 12 volt fan. So a 12 volt fan. And it tells us to take the 4 little rubber grommets off of it. These are basically on there to prevent vibration transfer. So not sure why we're having to take it off other than because of the way this is, the direction of flow, which if I can find it. Oh, interesting. Normally there is an arrow on here that shows the direction of the airflow. And I am not seeing it on this fan. But the air is normally coming in through here and out where the label is. That way, that's normally what gets covered up by whatever ducting or whatever that you're going to use. And we took these 4 little grommet pieces off because with them there, we're probably not going to get a correct seal on the printed part that we're going to be joining it to. So we took those off. Now we need to attach the duct to the back part. And that's going to be our duct and the back part. Let me see if I can't move some things around. And we're going to use some M3 by 16s. 3 by 8. Nope. We have a couple of M3 by 16s that come in through the back, and then a smaller screw that comes in from the front. That'll be an M3 by 8. Come on, darn it. And so I'm just going to go ahead and get my screws lined up in the hole here. So we're coming in from the back side at the bottom. Okay. And our duct is going to be, the duct work is facing down, right? So we're going to put it in this direction. We're just going to line it up and start the screw into our heat set inserts. And once again, I'm just going to take it until they snug up. Because I don't want to tighten everything just yet. And then I need an M3 by 8 to come in from the front. And so that's going to come in that hole that's right there. So one coming in from the front. It's kind of hard to gauge like the torque that you put in here, but you're tightening into a heat set insert. You don't want to crank on it too much because then you'll rip the insert out and then you'll be reprinting a part and starting all over. But you do want to get it pretty tight so that you've got a good airtight seal. Between the parts. So you want to make sure that these two parts, that there's no real seam, and I can still see a little bit of a seam there. I don't know if you can, but there's still a little bit of a seam there. This side's pretty closed up, but this side there's still a bit. So let me see if I can't. Like I said, be careful. You're just going to try and close it up as best you can. You don't want a lot of, you don't want to slack there because you're going to lose some of your airflow. Okay, that got it there. So we've got this little section done up. So 2 from the back, 1 from the front. Take care not to over tighten because you can damage the printed parts. And then we've got the fan. And I love where it shows us the look. The only place I could potentially see that where it might be would be there, but regardless, I'm not seeing any indication on here as to which direction it's going to go. Hey, Pezliz, how's it going? Uh-oh, heat wave. Hey, Glennon, Kit Skyfire, welcome in. Ola critters and undead English garden squirrels. A little bit of sawdust and wood glue would take care of that. Yep, yep, yep. Oh, can you fry an egg on the street pavement yet? I tell you what, I've actually, I lived in Tucson, Arizona for a while, and we literally had Black Flag days where, you know, you didn't take your, if you had to take your garbage down, you left it on the driveway and you hoped that when they picked up your garbage that they put it back down on the driveway because they left it on the asphalt, which is black instead of, you know, that light gray to white. They've actually had the wheels and the bottom of trash cans melt into the pavement in Arizona. Hey there, Creatix Brit. Welcome on in. It is so glad to see you streaming again. I was so glad to see that you started live streaming again. So we're going to need the 4028 part cooling fan, which we have sitting right here just for the time being. We're going to need 2 M3 by 35 countersunk screws. So these are going to be some long ones. M3 by 35. Interestingly enough, it's the first silver screws that I've used. Okay. And what's going to happen is the fan is going to go right on the back here. And does it tell, where do we want point the fan wires to this side? So the fan wires need to be coming out this direction. Okay. So the fan is going to mount just like this. So we need to bring our screws through the fan and then down into the lower part. And I may have to actually have to try and get these out of the first clip. There we go. So there's two clips there. I need to take it out of this one so I can bend it down out of the way. Get this lined up correctly. Here's one. Here's the other. Of course, these are going to be a 2.0. And we're going to screw these in, and these are going into heat set inserts at the bottom of this duct. I'm going to start pulling everything together. And once again, we need to take care not to over tighten. I'll probably jump over to the side view here real fast to show you what we're doing. Hopefully I can get a better view here. Nope, maybe not. Let's play with some angle maybe. So we've got this big duct that comes down through the back here, and that fan, it's sandwiched at the front, and we'll add more onto the back here in a second. But this is what we're looking like. Now we're going to prepare the tool head front, so this will be the front part that goes on. And a grill. So we've got a grill piece here, right? And we've got this little inset piece that's going to be facing down, I believe. Let me double check that. Facing down or facing up? Nope. The kind of printed inset is facing up. So the full flat side is going to go down. So this goes like this, and we're going to go in with two more M3x35 cap head screws. Were there more? Those will just feed down there, and we'll tighten these down. You went outside and the egg in your hand boiled? Oh, wow. Okay, so we tighten that down, and I'm just making sure visually, as best as I can, that everything kind of sealed up along that fan line, so we're not going to lose any of the airflow. So we got that part on. Now we've got the front part, and this will be the front part. So cooling fan for the hot end comes in this way. This little dodge over to the side here goes on the left side. So it's going to mount in just like that. As you can see, this tool head's kind of getting sort of wide and like deep. Not very wide left to right, but it's deep. And this gets installed with two M3 by 40 countersink screws through the top. We need to have countersinks here because this is what's going to allow us to mount our, still mount our extruder a little bit later in the process. So okay. So these are through holes, and they're going to go completely through this part and into heat set inserts that are down here. But these are kind of tight. So what I'm going to do, so I don't have to like go through and hand screw this completely through, is I'm going to grab my M3 reamer and ream that out to a solid M3. Right now it's probably about a 2.5 printed hole. And I'm going to want an M3 to make it easier for those screws to get through. And with me screwing into the heat sets at the bottom, it's basically going to just do a compression fit on that part. So we just quickly ream these out. Sorry about that. I just realized it was probably pretty loud in your ear there. Let me mute this for a second. Okay. So yeah, those were pretty tight on the holes, and I didn't want to have to sit here and screw all the way down through this printed part to get to the heat set inserts. That, and after screwing all the way through it, I would have been pushing plastic down into those heat set inserts, which would have been even more cumbersome and painful. Come on. Did I? Yeah, I thought I had all the material out of there. All right, let me try this one more time. Okay. So the other thing that we get with these is they become the like the piece that the belts go around as well, is these screws. So we're just going to push this tight in there and run these down into the heat set inserts. And once I start getting them into the heat sets, I'll work my way side to side to keep constant, or not constant, but similar pressure on both sides. If you crank one down, then you got to crank the other one in. It may be off kilter. And once again, tight, but not too tight. If you hear something crack, you've probably gone a little bit too far. So now that we've got this on, I just want to show you that there's two inserts right here. This is going to become the end stop for the X, and then we'll have our actual Rapido tool head go right here, and then our extruder will mount right here on this top plate here. But now it's time for the belts. So here's where I kind of need to jump back, provided it lets me. Yeah, that's the bed. We need to drop back one more. And we're to the belts. So once again, we didn't do the belts before, simply because it made no sense for me to do the belts and then go work for the bed and just have the belts flopping around here. Just didn't make any sense. So on our belts, we've got quite a bit of belt material here. It does say to cut this in half and run our belts, but I do want to double check that I did get a second set of belt material in the yes. So there is a second set of belts for the hybrid motored kit. So I don't have to worry. I can literally cut this in half and then route my belts. There's a part of me that, my soul's gonna die when I do that, because I think I'm gonna have a lot of excess belt, but I don't know. What do you guys think? Do we do the normal and kind of route the belt and then come back in? I think that's what we're going to do, is we're going to route the belt and then we'll come back and cut the other one to just about the same length. We'll leave them a little bit long, but that's going to leave me some more of this 9mm belt. If I cut it in half, I'm going to be left with two short lengths that probably won't be worth anything. I need to understand the belt path. So top side around the back here, round, back, over, top, side, and then back to here. Okay. I'm just trying to think where to start, because I'm not going to cut this belt loop. So I'm just going to come this way, and we're going to go around at the top back here. Get it to go around. I did, but it went down instead of straight out. There we go. So in this case here, as we're trying to get our belts wrapped around, we don't have a printed part back there that's kind of guiding us. We've got a, the actual 30-30 extrusion, right? So this will be the fun part because we're gonna have to bring it around the first one and then back around our pulley. I need to do that. Reach in and grab it. Maybe, hopefully. Where'd you go? Oh, there we go. So in this case, the belt's going to come around here, loop back around the pulley, and then come back around. So we're kind of bringing the belt back around on itself right here, it seems like. And I'll bring you guys in for a close-up once I kind of get this sorted. Darn you. Oh. Okay. So I've now got our belt routed somewhat. I say somewhat because I realize it popped down off of that one in the back. That's okay. We've got it literally. Okay, so we're coming around the back, top pulley, around the back, top pulley, corner over here. So top pulley on the corner over here, comes across, top back corner, around our pulley, top front corner, down along the back, around our front tension arm, and then around front pulley here and around. And we're going to do some type of loop around this side and then a loop in the back. So I'm not looking for a huge amount, but I'm just going to look for about right there. Like I said, I don't mind having, a little bit of extra. I just don't want to like cut this in half and then have just 2 small sections if I can have a big section. Yeah, belts, you need to pay attention. The belts on here, like I said, are really weird. Let me jump onto this. So we'll do a little bit of a flyby. So, here we go. So belt's going to come around the back here, top pulley, back in the corner of, around that top pulley in the back. Come along this way, around the back and the top pulley back here, which it's sagged down out of the top pulley, around the drive motor pulley. So this is where the teeth have to be engaged in the pulley. Back around here, goes around the front idler, front pulley. So this is the only place where we've got teeth against a flat pulley surface. And then we're going to come around, and this is literally going to go around the screw that we just put in place here. And it's going to get latched right up here. And I'll show you that once we get there. Right now, I'm just going to pull that belt back out, and we'll figure out the, the length for the other belt, and then we'll come back in here and route the belts for real. And once again, when we go to do our belts, right, we've got the belt I just cut, and then the belt that we need to cut. So we take the one that we've cut to length, and we put them together, tooth into tooth, with the one that we cut to length at the top. That means when we're at the end, that the one we need to cut will be longer by 1 tooth. So we'll cut the gap at the bottom. So all we're going to do is keep these together and just slowly work them through, keeping them tooth to tooth. And what this will do is just ensure, one, that we don't waste a lot of belt material, and two, it'll ensure that our belts are the same length. So it's not like we're starting with one that's 20 teeth shorter and it makes it real hard to tighten our belts. So now when we're like this, where we've got the end of the belt that we had previously cut and the new belt, what we're going to do is the first open valley is where we're going to cut, and that's going to make sure that our belts are the same length. So first open valley, we'll cut there. And that makes sure that we have 2 belts with the same length. And I've got enough belt material here that I'm probably close to being able to do a 3rd full run if I need to. So if one of these gets screwed up or damaged, I've got enough belt here. Just gonna lay this one sort of out there. It's a little bit short, but I cut it kind of long, so I probably have enough belt here to do another full belt run if needed. So, and quite possibly I've got enough here that I could probably do the 2 Y belts and have the entire Y belt. I'll at least get 1 Y belt out of this, if not both. And that may give me an entire other set of 9mm belt Once again, this is 9mm that I can use for future maintenance, right? So I'm just going to pull this back up. This is my excess belt here. Okay. Now we're going to go through and run our belts. Let me see, what do I want to do? Let me do, I'm going to do the bottom belt first. That's how I want to go. We're going to start by coming around front pulley here. Oh, got an ad brake going on. So all I'm doing is kind of rolling the belt back on itself the way that I need it to kind of loop around, and that'll make it easier to get it looped around a pulley. And of course, that gets me looped around the first pulley, and then the very next pulley goes in the opposite direction, so I need to kind of do the same thing. Just roll it in a tight coil the way you need it to go, and that will help get it started in that direction and hopefully make it easier to get it to go around the pulley where you need it to go. You know, I'm not a huge fan of iced coffee. I prefer regular coffee, but I will drink cold coffee, which I guess is literally iced coffee to a degree. I'm going to get my belt going around there. Pull some length. Now on this side, it's kind of like this one. We're going to go through the front pulley or the front idler around our of course, I did that backwards. And I should have known it from doing it over here. I need to come in with the teeth first over here. Why I normally try and start around the drive pulley and work my way back towards the tool head on both sides, because this can kind of be a pain in the tuchus to get it routed. Luckily, I came in from the side where I was going to be getting to the motor, I'll say sooner rather than later, which made it easier. If I had routed it all the way around and been about 2/3 of the way of running the belt and then gone, well, I just ran it the wrong direction, you know, that kind of sucks. Get that excess belt over there. Okay. So we're going to go around the front idler. I'll bring you guys in here real fast while I do this. Oh. Let me see if there's going to be a way that I can get you guys in here where I'm not having to fight with the wiring. Is it there? Yes, no. No, that doesn't get me the right angle. Okay. So we've got to go around the back side of this pulley, around this with the teeth. We've got to go around this, and we're going to come back around this back corner. And that's where this becomes a little more difficult, is we've got to go bring this in front of the rear pulleys, and then somehow get it pushing and going back the other direction, and basically do a 180 around that other pulley. Which it probably would have been easier to do it coming from the back there. Where I can see something a little bit better. Yeah, it keeps going into the 30/30. So I think what I might do is keep it out of there going this way. Probably not. I might pull this belt back out and start from the motor here, kind of work my way around, because if I don't, I'm going to be frustrating myself to no end. So once again, I'm trying to work my curvature. Bring it around the back here. Make sure we get around the pulley, back rear pulley. Go. Okay. That got us around the back rear pulley. And I can bring it back in front of, or back around this way on itself, hopefully. Now I see why they keep saying, hey, use some zip ties. Whoops. And I knocked you guys off. Let me see if I can put you there. 3D printed part for a little mini ramp, maybe? There we go. So We came from the back and we're going around the lower pulley and then around our drive pulley. And then we need to come back in here and get ourselves looped around this front pulley. Start coming up the front here. And we'll do the same thing we were doing before, just moving around this front pulley. Okay. So now flipping over to this side, we're going to be going around the lower pulley here. Hopefully. I'm going to lose you guys again. All right. I don't think I really have a good way of mounting you guys around here. This darn USB-C cable. Okay, there we go. So, come back around here through the lower rear pulley. Just lost you guys again. Sorry. Oh, come on, you little. Yeah, so this is kind of the pain in the tuchus, is just trying to get stuff riding around some of these pulleys because of the. All right, there we go, I think. You got to get them routed around the pulleys, and obviously don't have them ride up into the wrong set of pulleys or into the 30-30 extrusion, which is also a pain in my butt right now, as that did just ride up into the 30-30. Push it around a pulley, around an extrusion, without it riding up into the extrusion. I'll grab you all here in a second. No, 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 don't you dare. Okay. Whew. That was kind of painful. camera go? This camera. So once again, needing to come around here and around the lower pulley down here and come around without riding up on the pulley edge and coming up into the groove is kind of the big pain in the tuchus that we're trying to mitigate here. And then we'll bring it around, and now we've got to go around this and back out. So I'm probably going to try and use a zip tie here to see if I can't get that. And I'm sorry, I'm not going to be able to hold you guys up there. Really don't have a good method. Then like I need a thicker zip tie. Still have some in here. Should have. Ah, there we go. Thicker zip ties. Hopefully that'll help. And I'm going to walk around to the other side, because what I'm going to try and do is making a bigger mess over there. Need to see if I can't route this around. Like that. And then use that to guide my belt around. Not work. That did. What's going on there? There we go. Now, what I need to do, just make sure that my belt has stayed in the appropriate channels and hasn't gone all wonky on me. And it appears to have. So what we're going to do here at the front is this is going to loop around and of course it doesn't show that, but that's okay. We're going to go forward, forward, come down to where we're going to do the belts. Okay. So what we're going to do here is the belt comes in the side and loops around that screw that we put in there. Preferably, hopefully, maybe. Come on. All right. And I'll try and bring you guys in here a little bit closer. So we've got it wrapped around that screw in there, and there's a little bit of an indent, right, in that printed part. And that's where we want our belt to end. So it's going to sit in that indent. We'll pull the excess belt back through, but it's going to sit in that indent. And this piece here that's got these little ribbed edges and an open kind of spot there, this is going to get pushed in there, and it's going to go around, like between the belt and the screw, right? So we're going to wedge that in there, and then this is going to come forward. I'm just going to try and make sure to get that wedged in there well. It'll come forward, and we're going to put a screw in right here. And that will be a we put that in there, we do that, we rotate it forward, and then we're going to use a M4 by 10 countersunk screw. Three by 6, 5, 3 by 16, heat sets. M4 by 10 countersunk. There we go. We're going to use this to screw this piece down. And that's going to hold that belt tight on the front side here. So then we should be able to slowly pull our belt taut without dropping anything out. We want to make sure that we're still tracking everything right here. And the other side is going to go through the back. So once again, there's channels here in the back, like this top one will go through here, the bottom one will go through here, and that's going to it'll slide through. So let me get it lined up and push through the tail here. Going to get pushed through that gap. We'll get things kind of on. I'm not going to be like stupid crazy. I just want to make sure that it doesn't sag so that it comes out of the bearings. I'm going to take a quick look and make sure that everything appears to still be riding in the bearings appropriately. Not riding up on the edges anywhere, and it is. And so on this side, or on these sides, we're going to put these wedges in. Okay? And this wedge is going to go in, and it's going to be tightened from the other side. Darn it, come on. Okay. So belt is here. This wedge piece is going to fit in there, and we're just going to push it through. I'm going to try and keep my belt fairly tight. We're going to push this wedge through. Then we're going to come in from the other side with a long screw that's going to feed into this wedge, and we're going to pull it tight. We're going to pull this wedge in tight, which is going to cinch the belt up against the back side of the printed part. And that's what's going to hold it in place. And that's going to be done with, belt goes through, that goes in, and we push that piece all the way in. An M3 by 35. Now, it should be going all the way in there. It's not. I don't know if I've got it like wedged funky. See if I can pull this back out. I believe they're both symmetrical, so it's not going to make a difference which way I run these. Apparently it's not wanting to work its way out. Maybe. There we go. So I got it pushed in there. Now we're going to take an M3 by 35. Hey, fat boy, how's it going? Welcome on in. We're doing some, we'll call it weird angles for camera and trying to get our belts run. And we're only doing the main core XY belts at this point. But all right, it might be easier for me to grab my bond hose so I can come into it at a little bit of an angle. Maybe. Still not going to keep me from dropping the darn thing, that's for sure. So once again, coming in from this side, it's going to go into that wedge, and it'll pull that wedge tight, which will tighten up on that belt. The belt's not really tight just yet, but that's what we got those front idlers for, so. Can't tell if I'm getting into the, oh, there we go. Maybe. There we go. And we'll cut this excess off here after we get the other belt run. And seeing how much excess we have here, that tells me we're going to be plenty fine on distance on the remaining belt if we needed to ever, you know, pop one of these off and replace it. Okay, second belt. Where's the second belt? Here. So once again, we're going to learn our lesson, right? And we're going to come in from the back and try and work our way around. Because we need to go around through this back one. Back around our pulley. Come on. Keeping those things in line. Around the pulley. And around this idler at the top. Probably easier said than done right now. Okay. Around our pulley, or the idler at the front here. And what I'm going to try and do is lock it in on this side before I even try and mess with the other side. Uh-oh. Here's wedge for the back. Where's the other? Oh no! What did I do with the other clamping piece? Oh, there it is. That's what I knocked off earlier that I couldn't figure out. Okay. So once again, we're going to take this little piece right here and basically push it into the screw, rotate it around, and the teeth are going to get lined up in these grooves. And then we'll put a an M4 by 10 screw in it to hold it in place, and that will lock in the one side of the belt. be careful as you're trying to get that in, that you don't inadvertently crack that piece. I mean, you can always print a new one, but it so all of these parts were provided in the kit. You'd have to go and get the right material and the right color, probably from, what is going on here? Probably directly from RatRig, because I don't know of anybody else that does the color. Here we go. Pull that tight again. And now we do the fun part of trying to get around the top rear idler bearing back here. And keep it in the top rear idler bearing. Oh, yeah. Close, but no cigar. What I'm trying to do here is get it around the top pulley. Nope. All right, we're gonna have to use the, or at least try and use the oh, come on. Oh. Okay. No. Oh. All right. Okay. So that went through finally. And this is the tops. There should be a slot right there for this to go through. And then we'll have our other wedge that'll get shoved in there. Make sure I'm actually putting it in the right spot and not all crooked. Okay. Very good. So now we need another one of our long screws, which was the M3 by 35s. Where to go? 8 M3 by 35. And that will go in from this direction. Really should try and do this from a position where I can see. Okay. Well, I apparently did not get this one as tight as I should have. Don't know if I'll be able to get that wedge out now. Guess I can put the screw in from the other side and try and pull it out. So what's happening is I've got a lot of loose belt here, and that's going to cause me a problem if I don't get it pulled out. Doesn't have to be super tight, but it just needs to be snug without a lot of looseness, because if there's looseness in there, I run the risk of having the belts pop out of the correct path over here, and then we'll have issues. So hey, Shenanigans, welcome in. Welcome in. This is a pretty interesting way of doing the belts. Definitely works, and it definitely clamps things off, so that's good. Okay. How to get out of here without knocking a bunch of stuff over. Okay, so our belts are in. Everything seems to be good and lining up. Tracking well. Everything's tracking well. Nothing's coming out of its spot. Can probably adjust my pulleys up or down just a tad bit. So let me see about doing that. What I'm going to do is just crack the whatchamacallits. Move that pulley ever so slightly. Retighten them. And what I'm trying to do here is just make sure it's not riding on a flange. And if it is, then we'll simply about a quarter turn on the nuts, and that will allow us to move it slightly up or down. Uh-oh, what do we got here? Hey, Solar 3DP, welcome on in. Thank you so much for the gifted subs. That is awesome. Thank you, thank you. Okay, so this one's going a little bit better. This one, still not in the right spot. You just want to see daylight on both sides of the belt. So if you don't, loosen them up slightly and make some minor adjustments up or down. And then move that carriage again, and that will help that belt realign itself on the pulley. Both of those are good now. So we've got our belts on there. They're not tensioned. We do have plenty of excess back here that we need to cut off. That's the belt, blah, blah, blah. Cut the excess belt. That's like showing me cutting it like right at the end, which means if I ever have to take these belts off, trying to get them redone is going to be a pain. So what I'm going to do is I'm going to bring this forward, and I will cut the excess, but I'm not going to cut like, I still want to see a little bit of a reveal, a couple of ones on the side as a bit of a reveal in case I have to try and redo this. And like I said, if I do have a little bit of excess belt that I can leverage. So like I said, I'm not leaving a lot. I'm just going to leave a couple of teeth. And if I need to cut it even more, because it's riding into the side pulleys, then I will. But there we go. And welcome on in, Solar 3DP, and thank you for gifting the 5 subs. Let's see, you gifted a sub to Royal Nomi, Technoside 2, Makotronics, Nicor, and Vex, what was that? Vex 667. Awesome. Awesome. And thank you for being subscribed for 4 months yourself, Solar. Welcome on in. Hope everything's going good. And I just realized we're in a level 2 hype train as well. Holy cow. Thank you so much. How did that get started? Must have missed something. But thank you, Mr. Wizix, for 200 bits cheered. I appreciate it. Hello, there we go. Let me go ahead and we'll just turn over here and chat slightly. I can't really use my front camera because, well, there's a bar that sits like right in my face. So it doesn't really catch me unless I'm sitting down. And even then, I don't know if it would. So welcome on in, Solar. We've been building our RatRig VCore 4. This is a 300 size printer. As you can see, we've got our frame built. We've got our Z-axis in place. The bed is mounted. It will come back off to, mount the print surface and the heater and stuff. But we're trying to follow along to a degree. Like it wanted me to do the belts and then just have the belts sitting here flopping as we did the bed and then start building the tool head. And I'm like, no, I'm going to build the tool head, then come back and run the belts. And so that's kind of what we've been doing and where we're at. The goal was to get the tool head built and the belts run. And from there, then we'll see what the day brings. Maybe some electronics, who knows? We'll see. Night's still young. The night is still young. Let me see if I can get into our tool head here, or our hot end. There we go. So this printer, everything that I'm putting on here came with the kit. This is a very, very complete kit to include all the printed parts. All the printed parts already had the heat set inserts installed, and they were kind enough to actually give me heat set inserts. So all of the heat set inserts that I would have needed for this build are, did come in here, but they already had all the heat sets already installed as well. So like there's an extra set of heat sets. I still have a whole nother set of heat sets from a previous part of the build. So we also have the manta board, or excuse me, the octopus board, all the drivers and all that. I think the only thing that it doesn't come with is a Raspberry Pi, though interestingly enough, I think Raspberry Pi was listed in there as needed. But yeah. So thank you for coming on out. And once again, this is a Rapido 2, but it's a, we'll say the non-fiber Rapido 2. So here is our Rapido 2 hot end, rewired. which is nice. We've got a PT1000 thermistor, so that's cool. That's nice because that means we can get up to some high temps here. But there's the Rapido. This is the ultra high flow. It does come with the extra cables if you're going to need them, which we should not need them because we're going to be going into a Toolhead board. We'll also have everything to redo the heater if we need to. We have some thermal grease. We've got, there's the part that I was looking for, which was going to be the actual nozzle. So the Rapidos here, we've got a standard, so a standard 0.4 nozzle. And then we've got the extension, which makes it an ultra high flow with a what size are you? 0.6 hardened nozzle. We're probably going to run this in here because I don't have a 0.4. And the thing about this is you're going to have to heat tighten both the extension and the other nozzle. Oh, and let me double check this. Did we go with the... I gotta check and see if we can even do the ultra high flow or not. I have to take a couple things apart here. So we do have to take the groove mount off the top. And to do that, we've got to take a couple of the screws off, which are do not apparently want to come off. I fix it. Forks bits. Hey, Slab Stations, how's it going? How is it going? Hope you are doing well. We are working on our Rapido. And we're going to start off by undoing the screws and taking the groove mount off because we do not need it in this build. And of course, they were in there with Loctited screws, which always makes it fun to try and get them out, especially when they're these tiny, like M2.5 screws. Take those, and I don't think we need the ones from the actual kit here. But what I wanted to do is after I took that off, was I just want to kind of put this in place on where it's going to sit. Trying to figure out where the holes are going to line up. And make sure that I've got to make sure that my wires come out this side. And if I can't get the mounting holes to line up and the wires coming out the side here, then I would need to take apart the lower section here to clock this differently. But as it stands, it does line up. It will allow me to mount it in place and my wires to come out this slot here on the side. So that's good. What I want to also do is look here and just see if it will take the extra long hot end or not, the extra long hot end or not. And it does. Awesome. So, like I said, here's where it's telling us to line it up, and we want to make sure that our wires will come out this left side. If they're not going to be able to come out the left side, then we would need to change the clocked position. Yeah, and so in this, it shows removing the sock, and that's the extension piece, and then the nozzle itself. I'm going to remove the sock, and I'll show you what I'm looking at here. So there's the sock removed. We've got our heater with the wires that come up and just kind of come straight out. We've got an M3 thread on the thermistor. And then we'll have our adapter piece that will screw in. And then we'll have our 0.6 nozzle. So what we're going to need to do is get this in there. I'm going to leave the sock off because we're going to heat it up. And I'm going to heat tighten this lower piece. And then we'll come in, we'll heat tighten the M6 hardened nozzle. And that will give us our full piece. And then I'll put the sock back on. So I'll leave the sock off for now. And I don't think I need any of the M2.5 screws out of the hot end portion of the kit, because I think we will use the ones from the RatRig kit itself. And all this stuff will go back in here. I won't need the extension cables for the Toolhead because those will not be needed. We're using a Toolhead board for this. Whoops. A couple other things I can probably toss back in here. Those in there. I don't need the thermal grease. My one Rapido that I've used to date is in the Annex Engineering K3, and I am really impressed with that hot end. It's worked like a champ on anything that I put through it. So yeah, really impressed with that hot end. So let's see, if the cables in your Rapido align perfectly with the Toolhead slot, please follow the next steps. Push down on the silicone sock to remove it, loosen the set screw. Oh, if they don't, they do, we're good. We're gonna need 4 of the M2.5 by 4. No, Yeah, 5x6 countersunk screws. I have those here. We're going to be going through a metal plate and into the top of the tool head, which is going to be metal. I'm going to put some Loctite on those because I think that will work the best. So I'll put a little bit of Loctite on those when I go to install them. And good evening, Jedi Spidey. How's it going? Hope you are doing well. All right. Yep, I'm doing good. Just trying to get my tool head put together here. We got our belts run. That was a little fun trying to get to the rearmost idlers back there, but we got it done. Took a little bit of four-letter words may have escaped, so sorry. But we did it, and we're doing good. And I'm being careful that I'm applying a little bit of torque to those, but I'm not trying to really crank too much. That's why I put Loctite on them, because those little M2.5 screws are very easy to strip. Like, you look at them cross-eyed and they're going to strip. You look at them regularly and they're probably going to strip. So, yeah. The comment I could have made that popped through my mind, but I'm going to keep it to myself. Something about college spring break. But anyhow. So there should be a little piece of PTFE tube that's here, and there is. It's only chamfered on one end. Oh. And I'm honestly not liking that. I'm not sure if you can tell this. Let me see if I can't get you a good view here at this PTFE tube. Not sure if you can see. That PTFE tube, the hole in it is not centered. And I don't know if you can tell that by this, but that hole, there we go. It is not center, it is off to the side. So we're gonna use a different piece of PTFE tube. That is really wonky. What do I got PTFE tube wise over here? Don't need a huge bunch, but it definitely should not be 3mm inside diameter. There we go. Now what I need to do is match the length. I'll match the length. I'll cut me another piece of tube, and then off we'll go. We will not make it run tonight. Great thought, but no, it's not going to get running tonight. We have not installed any of the electronics yet. And so we're going to get, I think, close to the electronics tonight. Okay. I think that is close. Shade sliver too long. And like before, they only had chamfered on one side. I'm going to chamfer both sides slightly, because I like to make sure that it can not only feed in from the extruder well, but also be able to pull back out. Because remember, when you're doing, a filament change, you're going to have a little bit of a, I'll say a nub at the end where the filament was a little hot and pushed, or not pushed, but blobbed up at the end. And so you want to take that into account and make sure that you've got a slight chamfer on both sides. Because once again, if you look at this, there's a bit of, see if I can get it to focus. There's a bit of a blob right at the tip of that. And if you don't account for that when you're trying to do a filament change, you will actually get it stuck trying to pull it out, and you stand the chance of jacking something up trying to pull it out. And that would be bad. Okay, so next up, we've got our hot end mounted. We left the sock off as a reminder that we need to hot tighten both the extension piece as well as the nozzle. We don't need to do this because our cables are aligning and coming out the side as being directed. Mount it, and then we're going to stick the tube. So tighten the M2 6 screws, avoid using a ball head hex driver, which we didn't. Stick the 24.5mm PTFE tube down in there and shove it all the way down. We're going to need to prepare the X end stop. What do I do with the end stop? Well, I pulled them out. What did I do with them? Ooh. No. You guys let me do the X end stops. Not there. Not there. Put it in there. Screws, screws. What row, George? What do I do with the X end stops? Well, this could be a sad day coming. That goes there, goes up there. Down here, out of the way. And okay, give me a second, folks. I need to look underneath the bench and see if I knocked those off the bench as well. And I think I did. Thought I did. Guess I didn't. Or at least not there. Well, what the... All right, well, I may have to come back to the X end stops because I do not know what I did with them. This is really bad. Like, I know I saw them. I know I put my hands on them. I'm pretty certain I put them up here with everything else. Okay, so we'll work around the X end stop for the moment, and when I find it, I will install it. Yeah, because God only knows where it could have actually went to. Yep. All right, I'll have to look for those. Sorry about that. Like I said, it will mount to the side here of the tool head. No, they're not on the printer because they're going to mount to the side of the tool head here. And I don't have them. I've got the beacon, got the CAN bus board. I don't see it underneath the printer, so I didn't knock it up underneath there. I know I had knocked a couple of things off earlier, but I believe I found all the things that I knocked off. Let me give one last look over here. Yep, nope. Huh. Okay. I will continue to look, like I said, later off stream. It's nothing that, like, we're not going to be wiring it up just yet, so we can skip that for the time being, and I'll just remember to come back and do that. We're going to need the fan and the fan shroud. So here's the fan shroud and the fan. Hey, I found the end stops. So we'll do the end stops now. Pop up here. So we've got two end stops. They're exactly the same, so it won't matter. And they're just real basic end stops, right? Just open buttons. Open button, no lever. And it's going to get screwed in with, I believe that was M3x6 cap head screws. And it's going to get screwed right into these two flags here on the printed parts. So in essence, this is another piece that joins the front and back printed parts together. It kind of makes it one solid piece. Okay, and so this is just going to come over and tap right off the side there. And it does tap without coming off the rail or anything like that, so we're good there. We've got our other end stop there still, which will be the Y end stop. We'll get that added in a little bit probably. We've got our fan and the tool head shroud. So remove the sacrificial layers in the tool head shroud. And we will need to do that because there are sacrificial layers in there, so we're going to have to punch those through. You know, from the back, just take your M2.5 and push it through the back, maybe the 2. And try not to stab yourself because you're wanting to see if you can draw blood with a 2.5 millimeter head. That actually hurt. All right, so that's done. We're going to need our fan, which is a standard 4010 24 volt fan. We're going to double check that. DC 24 volt. So this is a sun-on fan. So pretty nice fan. And we're going to need 4 M3 by 16 screws. Okay. And fan the shroud. Which way do they want the fan wires to go? Through the fan, fasten into the RatRig toolhead front. Pay special attention to the fan airflow. It should blow air towards the hot end. Most fans have a small arrow indicating which way that is. And it does not show me which way it wants the wires to go. I've got fan wires this way. I've got hot end wires this way. I'm going to bring my fan wires up and around this way. That'll be my plan. Once again, M3 by 16. We're going to have just a shade of, a few threads popping out. But it'll be enough to get into our heat set inserts and get 2 or 3 threads through. So and once again, no need to crank the ever loving bejesus out of this. You don't want to crack the fan or the shroud. And interestingly enough, there is a slight gap between the shroud and the fan, which I never knew this, but if your shroud is right up against your fan, it could actually increase the noise that your fan makes because like that centerpiece is going to be tapping as it's getting sucked in. So yeah, I was like, oh, that's interesting. I never knew that. Uh-oh. Yeah, I'm not going to make it run tonight. We did find those, time to borrow from another printer. That very well could have been TechnoSlide. They're not already on the printer, and the Roomba has not been through. The Roomba stays downstairs. If I got the Roomba up here, it'd probably be able to do about 2 square feet of the floor before it starts running into things and just doing circles. So I actually have to clean and move things around and hand vacuum up here because it's such a mess up here. Now we're going to install our orbiter, and we're going to need 2 M3 by 8s. Oh, I know, but yeah, trust me, when I go through here to vacuum, I have to be very careful because I'm afraid I'm going to start sucking screws up and kill my wife's nice Dyson, and then I'm like in deep trouble. So remove the tensioning screw, remove the 2 front screws. So what it's going to tell us to do is right now our motor wires are coming out the bottom. That's going to get in the way, right? So we need to remove this screw so that we can unscrew the 2 motors screws, and then we're going to change the clocking so that the wires come out up here instead of down here. So we're just going to rotate that motor to make that clocking work. Take that out so that we can get to the two screws. These are M3 screws, and those little pancake motors, the screws actually, or the motors have threads on the little mounting ears. So you don't have to take the screws all the way out, just enough that you get out of the motor, and then you can physically just rotate the motor. (180 degrees). Slide it back in. Come on, slide it back in. There we go. And then tighten these screws back down. Now, one thing that I have thought of, right, is at the very least, I want a filament runout sensor on this. Okay, so I want to do a filament runout sensor on this. And when I do that, I keep thinking, like, do I want to go ahead and do a, get rid of the EBB 42 and go with the orbital 2 board, which literally plugs into the backside of the filament runout sensor when you put the filament runout sensor. So that is a thought. You're going to line this up, and it's just going to sit right down on there on your PTFE tube. And we're going to screw it down with the two M3x8s. Right, and this is not sitting 100% flush. It should be. The fact that it's not tells me that my my PTFE tube is just a tad long. You see that wiggle? That means my PTFE tube is long. And if I were to cinch this down, it's going to compress this tube and deform it, which will cause me problems. So I need to try and get this sucker back out. And if I can't, I'm going to have to try and trim it in place. Really don't want to try and do. What is my capability here? That's going to be too tall. That's not going to let me get on there. That is not going to go on there and give me the distance that I need. No. I do need a straight cut, but I also need a specific height or length. Maybe a do as I say, not as I do type of thing. Yeah, if you squish it between the hot end and the extruder, you wind up with basically having a bad day. Now, yeah, because if you get it in the, or if you get it squished down there like that, you're basically not going to have a like a 2 millimeter opening on your inside diameter. It's going to be too tight, and you'll wind up having all types of feed problems. I would say that I would never know that from experience, but trust me, I do. All right, there we go. That's better. I do. I've had that issue in the past. That's why I know that you have to be careful there. Yeah, extruder wouldn't feed, it would just lock up. It depends, because on the extruder type itself, it's either going to push the PTFE into the gears and then it's grinding against the PTFE, or like I said, it's going to compress the PTFE to the point where you can't get your filament in to the gears. What I'm going to do right now is I'm going to loosen that up slightly and see if I can actually get filament to feed. There we go. And now, mind you, this filament is the one that has that little bulbous end on it. So that's why it was so difficult going that way. If I go the other way, where it's just got a cut end, other than trying to play the curvature of my filament here. Darn it. So the orbiter has a metal, I was actually just catching on the gear. It's got a metal insert. So your PTFE is never going to get close to it. But if you don't have a, I'll say a conical tip, you're also going to have problems getting down through the extruder into that metal insert. Yeah, see, that goes in. And mind you, this filament that I'm using is also PCCF. So it's polycarbonate carbon fiber. And trust me, I love my Orbiter 2s. I've got one on, I love my Sherpas and I love my Orbiter 2s. Let me switch cameras real fast. So the printer right here, my 0G Mercury 1 build, has an Orbiter 2 on it. And the thing I love about them is you've got the macros when you're using the filament sensor. So as soon as the filament goes in, a ball squirts over and triggers an end stop pin. And it automatically does a load macro. So it'll heat up the hot end if it needs to. And as it's heating up, before it even heats up, it pulls the filament into the gears a little bit just to make sure that it's in the gears, right? Then it heats up the hot end, and then it will go ahead and do the, however much purge that you've set it to in the macro. And then if you want to unload it, there's a button. You just hit the button, and if it needs to, it'll heat the hot end up to the set temperature, which is I think 235, and then unload the filament. So that's why I love about the Orbiter and their filament sensor setup. It just works great. So I'm running that on several of my printers. And like I said, I love the way it works. It's a great system. Why that went to sleep, but okay. So now we've got our extruder installed. We've got our hot end in there. We've got our fan on there. We know we're going to have to hot tighten our hot end at some point. The other thing with the Orbiter too is it's got larger gears for the actual drive gears, and it's a planetary gear system. So it works really, really well. Now we're going to use some M3x6 countersunk screws right here, and we're going to install the beacon from the underside. So our beacon is a really, really cool product as well. It is a separate tool board. It connects via USB, and it will be managed just like another MCU per se. Yeah, or like another MCU because it does have its own chip, but it's also got an accelerometer on it. This is the Rev H, so it's got an accelerometer on it, and you're going to be able to, we're going to be configured, and you're going to be able to do both tap, or not tap, but contact. Not tap, contact. We're going to do beacon contact for homing, and then the beacon eddy coil, the eddy coil for the actual bed mesh. So we'll tap the tool head off, and this will sense the stoppment or the stop of movement, and then we'll this mounts. So this is going to mount in this orientation. So the USB connector is going to be up towards the underside of the tool head, and this will be your eddy coil down here. So it's going to mount like this at the back of our tool head using these two little M3x6 screws. And they're countersunk, which means we'll be using a 2.0 driver, which means I'm going to have to use my ball end driver because that's the only one that's going to have a chance of getting in there. Okay. Now, problem is this is where the bed gets in the way, and I kind of wish we hadn't installed it yet. But we're trying, for the most part, to follow orders of operation. So whoops. Trying to line this up underneath where you can't see anything. And once again, you're screwing this into heat set inserts using a ball end driver, heat set inserts, and small screws, and you're basically doing a compression fit on a circuit board. So don't ugga-dugga it. Sorry about that, folks. You went with the HGX Lite from AliExpress. I used the HGX Lite on the Rook 2020 Mark II because it's actually what was spec'd out. One second. Oh, it's what is spec'd out in the bomb by Canrog, and it works pretty good. It works pretty good. So now we're going to need to work at the back of the printer, or at the back of the tool head, and we're going to be installing our our cable wire tie holder. So we're going to have we need to thread the hex standoff on the LDO orbiter V2 screw, and it is this one, the higher one of the two screws. And we've got a hex standoff here. So this is going to get screwed on right here. Nope, too big. Printer tight's probably good. You probably don't want to really crank down on that. Yeah, do not over tighten the hex standoff. They are brass, and it is possible to strip the threads. That is true. Yeah, that is true. I've actually done that. And it's a sad day when you're sitting there trying to tighten down a hex standoff and then you shear the bolt off. Yeah, because I've done that too. Now we're going to insert the M3 by 35 screws into the tool head. So we've got two more of the M3 by 35 long screws here. And we see like, yeah, goes like that. And these are going to go down through the printed part. And of course, there we go. I'm going to have to try and figure out how to get them down in there. Oh, there we go. Okay. So the flat side is what's going to go right up against the back side of the motor here. And we're going into the two holes that were still left in that printed part. So we're going to go down through there. And like I said, I don't really want to tighten one down before I do the other. I just wanted to get the other one started down in there. Now it'll let me try and get this one lined up. So I feel like I'm not lined up though. There we go. All right, there we go. That's nice and tight there. Take care not to over tighten them because you can break the printed parts. Yes, you can split the printed parts here. Take one M3 by 8 cap head screw. And we're going to attach it. So this one came down through these two areas, and then the M3 by 8 is going to go through this side here and into that hex standoff. Okay, so one of the M3 by 8s. And it's going to go around here in the back in that hex standoff. So the how good I am at finding. And once again, don't over tighten it. You're just trying to snug it up to that hex standoff. If you over tighten it, you're probably going to strip the threads or shear the bolt, one of the two. Now we're going to take our Big Tree Tech EBB 42, the can tool board, and we're going to install it with 4 M3x8 cap head screws. And just like anything else, we get a ton of connectors for these boards. I cannot tell you how much like JST connectors I get from just Big Tree Tech boards. I can stop buying JST connectors at any point in time. And as much as it pains me, I may need to try and turn this printer around. Or no, I'll just go around the back and install it from the back. I'm going to go around that way. Over a bunch of stuff. So there's our tool board. We do want to, while we've got it available here, we do want to put the heat sink on the stepper driver. Doesn't tell us to do that, but yeah, you want to do that now while it's easier to access. I was about to say we also probably want to put the jumper on there for the 5-volt and then for the, but no we don't, because we're not going to run this as CAN bus, so I don't believe we're going to install like catapult and all that. What we're going to do is we're going to run 24-volt and power through the main connector here, and then we're going to leave it connected via USB. So it'll take power through, 24-volt power through our MicroFit 3, and then we'll still have the USB cable coming in here to provide communication with the GB, what is it, the STEM 32 GB01. And I'm going to have to get my adult eyes out, which is my 3x zoom on my phone in conjunction with my bifocals. Come on. That's a STEM 32. Yeah, and that's the G. That's what I wanted to verify. So your STEM 32 chip is the bigger chip, and then the smaller chip over here is your TMC 2209. That's what you want to put your heat sink on, not the GB, but the stepper motor. Okay? So peel that off. You want to line this up to make sure that you're not touching any of the other pins. Pretty tight fit. Just push down on it, hold it there for a couple seconds. Hey, 3D Medic Vents, how's it going? The bamboo, I don't think it uses a load cell when it's tapping the bed. It's using a load cell in the bed, and then it uses the LiDAR to scan the bed afterwards for the bed mesh. So it's using two different sensors to do it. Where in this case, the beacon is using its coil to realize that there's no movement, going down anymore. Okay. So M3x8s going into our heat set inserts into the back of this. And your USB and microfit connector, of course, are facing up because that's where you're going to be bringing your power and communications into the board. Oh, and I can already see we're going to be taking this board back off to be doing some of the wiring because it's got them small screw down terminals for the hot end wires. And yeah, I'm not getting to those without taking this board back off. So, but we'll probably get into that Thursday. I don't think it's going to tell us to start putting toolhead wires in tonight. That will be in the electronics section, I'm sure. Darn it. Okay. Whew. The board's now installed on there. Right here. And what now? Your V-Core 4 now has the RatRig Toolhead installed and ready to melt some filament. Negative, Ghost Rider, because there's no electrical connections. Gantry alignment. All right. Let me see what we got. We've got an M3x5 set screw. And this is going to be used, there will be a piece of wire that comes somewhere over here, and this is going to be used to do a set screw to hold said wire in place. So do not lose that little set screw. I'm going to put it in here with our other end stop because I would never, ever lose the end stop, right? Just for like a good 20 minutes I did. That's extra. These are out for tightening the tool head when we get there. This was used as a tool to do some belting. Need coffee. Okay, so where are we at? We've got a tool head fully built. Let me bring you guys on a quick fly through. So we've got our belts installed. We've got our RatRig tool head installed. The belts are there. We've got a big 4028 fan that's going to be providing our cooling to the hot end. We've got our EBB 42, and this is where I'm saying is we need to install the hot end wires right there coming up from the bottom. That ain't happening. I mean, we're going to have to, we'll bring these around. We'll have to cut the end off, and then we'll bring them around and plug them in. But we're going to have to take the board off to get those in once we figure out the size or the length. The Extruder wire is going to come around here and go right in there. That's going to be nice and tight. We've got the beacon probe mounted underneath here. So we'll be plugging the USB cable in there. It'll come up and join with the cable loom coming around. And now we're going to start working on our gantry here, and we'll try and see. I may have to bring you back into a fly-in. Let me see what we're going to do for the gantry. Push the X gantry forward. The space between the XY joints on the front bumper should be the same. So I just brought it all the way forward. And what we're going to do is just make sure that they're gapped the same right here. After installing belts, it's normal for the gantry to get slightly twisted. I'm assuming twisted due to the forces of the untuned belts. If the space isn't equal, right, we're looking for equal gap right here between the printed part and the metal part. So this gap right here. So that gap and that gap. And they look about the same. There's a little bit of squeeze there, but there's also a tiny bit of squeeze there. So I think we're pretty good as far as that goes. This kind of shows an exaggeration here of, you know, if you're, you know, we're looking for this type of gapping, right? Which I think we're really close to, is that type of gapping. And if we're looking like this, nope, sorry, wrong one. Went back on me. If we're looking like this, where there's a big gap, then we've got a big issue, which we don't. We seem pretty good on both sides. This is what we would do if it wasn't, is loosen the M4x6 set screw, slowly tighten or loosen the cap screw on one side of your belt tensioners or the other, and then that will bring it into square. So tightening it is going to bring that edge closer. Loosening it will let that end go out. Like I said, I think we are really good there. Yeah, I think we're really good. We might have just a shade on this bottom side here. So let me give it a thought of like a quarter turn. And by the way, the gap that we're seeing here is because it's hitting the tensioning arms is what it's hitting. So I think we're good there. Just both belt tension screws until the gap is equal. Both sides of the gantry sits flush. Squeeze the XY joiner against the front plate to feel if there is any play. While squeezing, there shouldn't be any play. I have no play. On either side. tighten the stepper motor pulleys. Move the tool head around. Ensure the belts take their natural, and this is where we're going to adjust these two pulleys back here, which we did earlier. We basically did this where we were moving the tool head around and making sure that the belts are riding in the pulleys with a slight, like ever so slight, like half a millimeter, maybe like a 1/16 on either side of the belt. And that's what we're doing here, is just trying to make sure that the belt is lining up on these pulleys right, so it's not grinding on the edge of a pulley. And we're good there. So now we've got some accessories that we can install. And this is probably going to be the last part of the night, is doing this. Now, all of these accessory parts that I'll bring out and show you, going to start off telling us to put in heat set inserts. And going to tell us to put in heat set inserts. And once again, heat set inserts are already installed. So 1, 2, 3, 4. Be doing that piece. I think we need these 4 pieces. Right? So all of the trim insert pieces. That piece, do the thingamabobbers on there. They're done. So 4 front, 4 rear. I don't know if there's a difference, or I guess there is a difference between them. The front are these ones. And oops, the rears go into a different spot. So the rears are the ones that are on the inside. So these will be the rears over here. These will be the fronts. We'll have this piece back here with a set screw right there, or the heat set insert. This is going to be for putting in the wire, I believe. And then we'll have our end stop, which also has the heat sets in it. This will be the Y end stop. And we're going to start with the umbilical frame. And we're going to need M6x12 cap screws, 2. We need a couple of our hammerhead T-nuts. We're just going to go ahead and get those put in there. Okay. Loosely thread the 30-30 T-nuts into the M612 screws. Do not tighten at this point. And then we need the one set screw that's going to go in the back there. so what do I do with that set screw? Need to grab that back out here and go ahead and put that in. Okay. So that screw is going to go in there. I'm just going to get it started. I'm not going to go all the way in. But you'll see there's a spot right there at the top that the wire will go down into, and then we'll use that set screw to lock it in place. This goes on with the outer opening towards the back of the frame. So the set screw is on the inside, the opening is on the outside. It's going to allow our wires to come down and go out at an angle. This will go in there just like that. And where's my, there it is. We're going to center this. Can't tell it. All right, both of those turned. Okay. So we get that installed, and like I said, it should be centered. Don't over tighten them, you can damage the printed parts. Yep. Now we need our other end stop. So we'll pop that out. Need a couple of M6 by 12 and roll-in T-nuts again. And 2 of the M3 by 8 cap head screws. Actually, not 2, 1. One of these. And M3 by 8. So how you doing, 3D Medic Vents? Hope you're doing well. Hope everybody's enjoying the stream. Hope everybody's enjoying the stream. We're going to look at our part like that, and it's going to mount in there like so. So our connector is going to be facing up where the M6 bolt head is. Going to get this lined up and get the screw started. Okay. So that's what we're looking like. And this is going to come over here into this front into this front corner over here. And our connector faces down, so it's going to go in like this. And it's going to go in this very small hole, or this small gap, I should say, right there. Care not to over tighten. And we're also going to want to make sure that it's straight. Huh. And it hits before it contacts. So I have a feeling I'm going to have to tighten these lower, or the belts up some, to get it to be able to contact. Repair nozzle wiper. Okay. There's those parts, and the other parts should be some type of like foam matting, which I have not actually seen yet, or I don't think I've seen yet. Whoop, maybe I have. Felt pads? Yeah, felt pads, okay. There's the 4 felt pads. And we're going to need 4 of our M3x8 cap head screws. So they want us to bend the felt pads basically in half. Now the question is do we have to take the, I guess this is like a self-adhesive sticker. Take that off or not? One, it didn't tell me to take it off, and 2, I'm not sure if it's going to come off, but we want to fold these in half. Yes, that does come off. We're going to fold these in half, which will have them stick together. Form a little U shape there. Whoops. Oh. work to get the sticker thingy off. Probably be a lot easier if I didn't just trim my fingernails the other day. I'm going to break out the X-Acto knife. Okay, so this is fun. Never thought of using felt pads for stoppers. Like silicone, yes, but not a felt pad unless it's just being used as a nozzle wipe instead of a parking location. It may work for that, but if you've got close contact with it for any length of time, I think that, you know, a 240 something hot end would cause problems. So we've got these. We're going to take two of them side by side, and we're going to put it in the left wiper. So that's the L. And it should fit fairly snugly in there. So just like so. Okay. Squeeze the two left pads together while inserting in the wiper body. Repeat the step for the other wipers. Okay. The same thing for the other wipers for the right-hand side. So we've got the left and the right. And the left goes over here with a couple of our M8 screws. M3x8 screws. And the nice thing is you'll have both the wipers in place so that, you know, right now you're not going to really need it, I don't think, with just the one tool head. But if you go to do the IDEX upgrade, it's already there. It's not like something else that you have to do when you get to that point. It's already set and ready to go. And I kind of like, you know, the X Gantry came with two carriages on it, and it actually gave you the little the carriage, whatever they call those little things, strips that you can put the carriage on, and then it says put this aside if you ever want to do the IDEX. You're going to need it then, because the IDEX kit will not come with the other carriage because they've already provided it to you in the base kit. So both of those are installed on each side. Now we've got, like, why'd you ask me to bring these out if we're still not going to install them yet? We've got a set of parts in here. We've got a 3030. And some parts there, some parts there, and some PTFE tube that we'll get to in a little bit. So this stuff right here is going to be for our spool holder, which is going to go down here on the side. So there's the edge of the kind of like that they do the shrink wrap, but I kind of hate it at the same time because it's kind of a pain in the butt. But depending on where they do the ends, you can't find them. Easily get it back off. Okay, so 3030, couple of corner brackets and stuff. So we're going to take this bracket and we're going to do a couple of M6. Look, and all the hardware for it is actually in here. That's awesome. Some 6x12 and a couple of M6 roll-in T-nuts. That installed there. Throw it on the floor because we haven't thrown anything on the floor. Well, no, we did throw stuff on the floor earlier. My bad. Okay. We get our two M6 by 12 bolts on there with the T-nuts. Wants us to put some PTFE tubing in there. I didn't see any pre-cut lengths. I just saw the big set of tubing in here, so it wants us to add some tubing in there And we'll do like we do with our Vorons, and we'll just slide our PTFE tube in there and then cut it right at the, we'll cut it off right here, and then we'll do the same thing on the other side. Okay. So there's our PTFE tubes done. Take this and put it back down here for a little bit later. Now we're going to start to get our corner block here. Now this is a 30-30 corner block, and these things are aluminum. They are pretty darn beefy too. So we're going to get another couple of M6x12s and rolling T-nuts ready. And we're only putting them in on one side. And okay, loosely done. Now we're going to take this and install it in our 30-30 tube here. And I'm going to use my bed to make sure that everything stays nice and flat at a 90-degree angle here when I tighten this up. Okay, so there's that. We're going to have a top block piece. Right here that's just going to go on as a cap. This decorative cap to cover up the cut end. And we're ensuring that the extrusions flush with the printed part. What printed part? Aluminum angle. Okay, now we've got to pay attention. Our angle's coming towards me, which means that our spool holder arm comes off to the left side here. We're going to kind of line that up so it's at the top. And I believe where it is at the top flush with the printed top piece. And we'll tighten the bottom. Tighten the top. This is what we've got. The angle, and then our arm comes off the side there. And now on the spool mount, spool can be mounted on either side of the printer. But with the, it's funny because they made me do it this way, and well, they didn't make me, but it goes over here. So if we're going to put it on the left side, then the spool holder goes this way with it off to the right. If we go on the other side over here, of course, we'll go on this side and it'll be off to this side, you know, coming in this way, right? But either way, we're going to take the two center bolts out and use those to hold down the spool holder. So let me think. Which side do I want to go on? Because it shows the left, because here's the two front screws. So it shows putting it here on the left. It says you can put it on either side. So you remove the screw and the washers, and when you put it back in, you only use the screws to put them back in. But you're using M6x16 cap head screws, which are in here. Then we'll have some trims to work on. What do you guys think? Left or right? I'll leave that off for now. We'll make that determination left or right here in a little bit. Kind of because I'm going to see where they tell us to work the PTFE tube. Because once again, the goal here is that you'll be running all this stuff internal. So you won't have a spool holder going outside the printer. It'll all be inside in the printer. Which is actually a pretty good idea. Okay, we're going to start working on these parts up here. Okay, so prepare the front and rear trim parts. Put in some two M3x8 cap head screws. Will be used to hold an LED PCB module coming soon. Ooh. That's just one of the rears. Assemble an upper corner bracket. So M6x12. I need a few of these, so I'm just going to get a few out. Nope, not those. I need the other aluminum brackets. And of course, each one is in a separate package, so two of these we're going to go ahead and get all 4 screws in with our 30-30 locking nuts, or locking nuts, 30-30 T-nuts. So 1. Okay, 2 are prepped with all 4 nuts. 2 and 2, or 2 of these prepped. All 4 have bolts and T-nuts on them. Yeah. Install the lower corner bracket. Take out the M6x12 cap screw and the washer. Okay. So there's a cap screw and a washer. And we're going to install a corner bracket that only has 2 M6x12s and T-nut. So get the T-nuts lined up, slide it down. Tighten the M6x12 screws to attach the bracket, and then do an M6x16 straight down. So we want to tighten them to the side first. And then we need an M6x16 that goes straight down. That's an M616 without a no washer on this one. There we go. Install the remaining. The upper corner brackets have the 2. Install the upper corner bracket. Tighten the M6x12s. Repeat steps 27, 28, and 29 to do the rest of the brackets. So we're going to do the other lower one over here. We're going to need, I'm going to take this M6x12 out. And recover those 2 M6x12s and the washers. So I'll put the washers back in the washer bag. I'll use these over here. And we're going to do the same thing we did on the left side. We're going to take our part here, get it lined up, slide it in place, straight down. We'll tighten this up first. Kind of holding it down in place. Tighten those down, then we're going to need an M6 by 16. And we'll bring that down from the top directly into the T-nut that was still sitting underneath there. Careful not to knock it out of place as we do this. Okay. Then our other two corners here are going to go, I'm not going to be able to get, they're going to go up here. So get one side lined up. We'll work to get the other side lined up. Hold it into the corner and tighten up our T-nuts. Corner ones are a little bit, you know, they kind of fight with each other. If they had used button head screws here, it would have been easier, especially on those corners. You can kind of see right there what I'm talking about, how these two are really tight to one another. If they had used button heads, it would have worked a little bit easier to get those lined up. All right, so we've got our two upper and our two lower brackets in place. Now it wants us to take our front pieces, which have the openings. We're going to put one of our little accent pieces in. Making sure it's fully seated in there. And then this just pop in there. And then that one goes in, then a rear one goes in. Is that right? How does that work? Trim front, trim rear, trim diffuser, M3 by 16 cap head screws. Okay, so the M3 by 16 goes all the way through the back. Gotcha. M3 by 16. The good news is we're working through a lot of our material, so not like we've got, well, that's M4 by 16, M3 by 16. So it's a little bit easier to find the screws and stuff we need, as long as I read the difference between M3 and M4, because all I saw was 16. Like, what's going on here? The holes have the sacrificial piece in them, so let me pop those out, hopefully without stabbing myself again. Hey, Pete, how's it going? How are you doing, my friend? So these pieces here are pretty thin. You got to be careful that you don't stick your finger through some of the sidewalls here, but been a rough week so far. I'm doing pretty good. I'm with you. It's been a fun week so far because we're doing it's the end of Q4 for us, as well as the beginning of the fiscal year FY25 for us. So it's a little bit crazy, to say the least. Now we're going to do this on all four corners. So once again, our one that has the holes in it, these are little pieces that will slip in there. And gently just push it down there. Be careful. This wall is very, very thin right there. And you can stick those in the front of your corner brackets. And I believe, like it was saying at some point, that these will have, we'll say, the option for lights. So these corners will be backlit. And I'm not going to bother putting these little M3 by 8s in here because I'll have to take these all apart anyhow. So I'll put these back in the baggie. Whoops. M3 by 16s. Those out there. And so what's happening is we need to punch holes through the sacrificial layers on here. And then like we just put this piece in from the front, this will come in from the back. And then there's going to be two places where we put in M3x16 screws. And the screws that go in here will go right into, all the way through into the front piece. Darn it. And it just covers up the metal angle brackets to make it look a little bit nicer. So the happy trim piece is what it turns out to be. And it prevents you from getting a bunch of crud in these corner bracket areas that you would have to like vacuum out and stuff. So kind of helps keep the inside of your printer a little nicer. And as you can see back there, we still have the Milo sitting over here on the floor. Hasn't gone anywhere. Like I said, I'm going to have to take it out into the shed and work it out there to bring it online and check things out, because that's the only place I've got a 20 amp circuit to play with, is out there. And the the VFD for it requires a 17.5 amp circuit. So yeah, we're gonna have to take that out to the garage, or the shed, to work on it, to get it started and all that good stuff. Because if I try and bring it up here, I'm afraid I'll drop everything again, pop the circuit. So is your rough week like work related, or? Because I can tell you, this right here is making my week better already. Just chatting with you all and building a printer. Okay, we got one more, and it's the one up here. Whoops. Ugh. So let me bring this one back up here and I'll show you kind of what I'm doing. So I've got the front piece in here, and we're going to bring the back piece in with some a couple of M3x16 bolts that go through this back piece. And then these heat set inserts right here will be used for a LED board in the future. And those LED boards talk about future planning and provisioning. There's another hole in the top of this right there. It comes down at an angle. So that's how you'll run the wires in for the LEDs that will backlight these little front pieces. This will go in the back side of that big angle bracket. We'll tighten these screws up and sandwich these printed parts on either side of that large 30-30 angle bracket. And so this is what we're looking like. So those aluminum angle brackets are covered up with a nice trim piece here. And these are just light enough that if we get a good bright LED back there, these will light up. And until then, the neon green type color that we've got there, RatRig green, will shine through and be perfect. Okay, so we've got the four corners on. We have an upper PTFE guide. So let's see, what does that look like? Not that. Be a black part. Should be a black part, and it should probably be in here. Upper PTFE guide here. M6x12 and a roll-in T-nut. Not a roll-in, but a hammerhead T-nut. Then we'll have the Bowden pass-through adapter. And this gets mounted on this side. And there are some printed threads, but we want to be careful and make sure that we're going straight in there. And we're going to carefully, hey Pez Liz, how's it going? I bet you didn't think I would still be going, did you? We're going to take this and gently screw it down here. You got to be careful here. Thread the bottom adapter into the printed part, secure it in place. Take care not to over tighten it or you will snap the part. The walls of this part are pretty thin. And we're just snugging it up and done. So there we go. You never left me? I see. You were just quiet as you were multitasking through various streams. So the upper PTFE guide assembly, we're going to install this assembly to the left back side of the printer. We're going to just set it in place and tighten the M612 right back here in this left corner here. So slide this forward. That lined up. We'll slide it all the way over to the side. And secure that in place. Insert PTFE tubing through the Bowden clamp as shown, then connect it to the orbiter extruder. Okay. And we'll have lower PTFE guides. And these are the other parts here? Yes. So these have a slot in them, and they, right? So they kind of clamp. So we'll push our PTFE tube through there, and then it'll clamp down on that. Now, I think I want to see where these go first before I do anything outrageous like run PTFE tubing just yet. Kind of don't like that these are somewhat threading, so let me grab my whatchamacallit, my reamers, those things, yeah. 3, 4, 5, and 6. You see I'm just doing that by hand. Now if it's a long hole, then you're probably gonna have to use the drill. But on a really thin hole like that, you shouldn't really use the drill. You should be able to do it by hand. And it keeps you from slipping or doing any damage. because this is a clamping fit, I did not want um, the bolts to be threading in, because then it could put a preload on the clamping piece and cause us problems. So PTFE guides, set them up like that. Yep, yep. Those run down the side. Now, okay. Run PTFE down through there and do that, okay. Makes sense, especially if you wind up running two separate tool heads. But I think what I want to do is with my PTFE tube here, let me get these zip ties. Now I think, and I was reading about this, that this is 2 millimeter inside diameter PTFE tube. And some people were saying that it's a pretty hefty bend to make. So doing like 3 mil wall is not good, but 2.5 might be better. But what we're going to be doing is going through these two, right up the side around the motor mount, and then up through here, and then up to our tool head. So we just have to be cognizant as we do this that we don't kink our tube or make it so sharp a turn that we have an issue with feeding the tube or the filament into the tube and creating a whole lot of drag, because that would be bad. So what I'm going to do, since I only have a single tool head, is I'm going to move this fully up to the front and over to the side. And that tells me how long my PTFE tube needs to be to reach my extruder. Okay. Take the clip out. Come here, clip. Take the clip out. Put our PTFE tube down in there. Put the clip back in. Okay. And it's relatively decent, right? We don't want it too tight. Now, the way this thing shows is it shows doing our first mount, like kind of tucked in right over here. And that to me kind of looks like a crazy bend to be making in a PTFE tube, right? I'd want something like that, not too bad, but it goes around the side of the motor, doesn't go behind the motor. So that's not too bad. And then the other one is going to be down at the bottom, but we have to be able to bring our PTFE tube down in a straight line over here. So we don't want it too high up that it can move around a lot down here, but we don't want it too far down that it creates a crazy bend at the bottom coming into our spool, right? So I think that's about it. It shows it going way down low. I don't know about going too much lower than that, because then it kind of can get iffy there. And we don't want to clamp this so tight that we're crushing the PTFE tube. But we also don't want it so that PTFE tube can get pushed out. And what we're going to do here as well is we're going to go ahead and put our spool holder over on this side, which I think you can see if I do this. Yeah. So we've run our PTFE tube. It comes down here into the motor mount, does a little jog around the bottom of the motor, comes down the side, and then it's going to roll forward here. And we're going to take these two out, and that's where our spool holder is going to mount. And our spool is going to be able to roll just like this. So we'll take these out. When you remove these, you got to be careful to remove them straight up or double check that your M6 T-nuts stayed centered in there. So when you go to replace these, they're still in line, because you're not going to use the washers. We'll put those back away. We'll put these 6x12s back over here and where we have them. We're going to grab a couple of the M5x16s. Keep saying M5. These are M6x16. I've been saying M5 the whole time, and they're M6, but you guys know what I'm talking about. Uh-oh. Okay. And so once again, our spool is going to go here and unwind into this direction. So this we're probably going to cut somewhere back here. I don't see, it doesn't give me an actual distance. Just kind of looks like it. You know, it just looks like it comes down here and goes over. In fact, I put these on the inside here, and it looks like they actually go on the, I put these on the wrong side of the extrusion. Let me see if I can get these undone. We'll put those on the correct side of the extrusion, and which means they're not even on there. You know what? I don't think it's going to matter. I'm going to put the, I don't think it's going to matter. Whether it's on the front face or that side or the rear face of there. I don't think it's going to matter. And like I said, this is going to come forward, and I'm just going to cut it off kind of right by the base of our spool holder. Actually, it looks like that PTFE tube goes all the way to the back side of the spool holder. So that's where I'll cut it for now. And I do have a bunch of extra, probably not enough to do a full run, but I do have a bunch of extra still. So that's always good. Okay. What else do we have going on here? That goes away. We come back to this window. And like I said, it looks like these should have been mounted here, but the only way I can do that is to pull them completely out and put them back on in a different direction so I can mount them here. If somewhere down the line that becomes an issue, then I'll worry about it. If not, then we're good for now. And I just kept this kind of long to where it'll come right along the edge here to about the front. And if we need to cut it shorter, we can. Filament routing. So yeah, if you look at this kind of looks like, let me go back over here to full display. You know, this just looks like a heck of a crazy bend, like sharp 90-degree angles here. That, like the big loop at the top, perfect. But it's this loop around the motor and then the one down at the bottom that just makes me cringe. I hit your face. Haha, I meant to write that to Glendon. Only violence for Glendon. Okay, well, I'm glad that I don't inspire violence in you. Yeah, see, that just looks like a poor routing. So I'm leaving it a lot more gentle in the way I'm running mine. Whoops. Oh, crud. Dang it. Dang it, dang it, dang it. I just went out of the Suzuki manual. Let me see if I can pull that up out of history. There we go. Yeah. So I'll bring you over here with this camera and just kind of show you how I made it a little gentler. So we're coming down here. We do kind of a gentle S-curve instead of that sharp S-curve. And then down at the bottom, you know, I left this high enough, didn't bring it all the way down, that we're going to get a pretty gentle turn. And if I need to, I can move this up a little bit more to give me a gentler bend there to keep from having issues loading filament. Okay. Now what's next? Piano wire for the umbilical. So we've got the M3x5 set screw back here already. The piano wire needs to be cut to length for your machine. We need 650 millimeters for my build. And I've got a full meter. So I'm going to have to cut this to length. And hopefully my bigger wire cutters will cut this without an issue. You got to be careful with this stuff. And the way they put it in there, I like that. They use lengths of PTFE tube to hold the ends in. You got to be careful because this stuff is really, really springy. And you do not want this to flip out and hit you in the face. There we go. We'll need to find our 650 millimeters. So let me grab my meter stick out here. I'm just going to do this down on the floor because it's going to be the easiest way to do it. .650, bigger wire cutters. Go down at the base, so if I damage it, then I don't damage important parts, and sure as hell did. It cut it, but it cut it, but you can see the divot that it just put in there. Teeth. See right there? Tell you what, this piano wire is crazy. Okay, so I'm assuming I'm going to need the longer piece and not the shorter piece. Shorter piece we'll toss over here, and I'll cut myself on it 5 or 6 times before I do something smart and, I don't know, move it somewhere. And yes, that was me falling down because I crouched and lost my balance. The good news is it was like 6 inches. Bad news was, well, I'm not sure if that was on camera or not, but you at least heard it. Okay, so wire goes in from the top, the designated hole. So there is a hole right in the middle back of this printed part, and we're going to flip it down there. I'm going to try and go all the way, and what I'm going to do is actually put my finger there, pull it back out, and see how far down we went. And it looks like we went all the way down to where the extrusion is, because that's how far down it went. So that was good. That means my set screw wasn't in the way. I can drive that all the way down again, and then I need to do that set screw, which I really should not be using a ball end for this, but unfortunately, my 1.5 regular, I snapped the tip on. But that's in there nice and good. So that side's in there good. Then we bring it and we insert the other end somewhere on our tool head. So it's showing a hole there, but I'm not seeing a hole. Oh wait, it's in the face of the EBB mount, maybe? There it is. Okay. Super stiff, do not allow it to swing freely. It can hit you in the face. Once installed, it should look like the picture. The piano wire will provide support to the USB and power cables, improving input shaper results. Nice. Yeah, you got to be careful with these. trust me, I've gotten enough from KB3D Chris that if you're not paying attention to these, they will smack you in the face. They will smack you in the face and it will not feel well. And I believe that's in there as far as it's going to go, or at least as far as I can shove it. So okay. So what's up next? Electronics. And just like that, folks, we are into electronics. It's 10:30, and we're going to call it a night, because when we go to the electronics, we're going to start seeing that we're going to work on the control board and things like that. We're going to build the electronics enclosure, which means the printer is going to come off the bench and go on the floor beside me. And we will be up here building the electronics enclosure. And then with the electronics enclosure done, we'll mount the back panel, because the electronics enclosure will mount to the back panel. So what I'm going to do is just kind of put these screws away, clean things up here. Beacon cable, that cable. Two, which makes that 2.5. This is a 2.5. Big Daddy. This goes over there. This will be used later. That will be used later. This, I'm going to go ahead and put over here on that. So the clip that came with that. So, yep, these wires, that. Okay, I think we're doing good, folks. As I mentioned, we have a couple of things left to do on the printer itself, which we'll get into once we start doing all the electronics. We'll be wiring up our board and doing all that stuff. I'm going to try and set this down on the ground now. Hopefully you'll hear me get my, my third hernia of my life. And then we'll grab the other stuff and get it up here and ready to go. So that wasn't as bad as I thought it was. Hey, we got a desk. We got a desk. So electronics wise, we'll have our Victory-Tech Octopus. We've got our power supply. Go ahead and pull that out. It's a LRS 200 24 watt power supply. You'd only need a 200 because the bed is a mains heated bed. What else do we have? We'll have the wiring kit. Seems like a lot of wiring, but that's the wiring kit. Put that up there. The whatchamacallit, the solid state relay. I did not see a whatchamacallit. I did not see a Raspberry Pi in here. Like I said, it sounded like there would be a Raspberry Pi. I did not see a Raspberry Pi. In this box, will be our electronics panel. Once again, it's a backpack. So all of this will get put on the backpack, and that makes more sense now because here's a bunch more wires, which, thank goodness, because I was like, that's not a whole heck of a lot of wires there. Ventilated sides. A cover panel of some sort. We've got 4 corner brackets and two more sides and top and bottom panels. So there we are. This is what will be ready to start and raring to go on. In the next stream, we'll go ahead and build the case. And then, oh, sorry, I'm just trying to look through here. So electronics, we will build our, thank you. We will wind up building our case. We'll prepare the board. Yay. We'll build the case. Two different types, whether you have a steel or an aluminum. This is the aluminum. On the steel one, you'll have printed parts. I believe I actually have the printed parts, but we've got the aluminum one. And then once we have the case done, we'll just start assembling and getting power supply and everything fitted in the case. I believe we do the firmware and stuff for the board before we install everything on the printer. Maybe mistaken. There's the rear panel. Mount the rear panel, mount the electronics. Nope, looks like we mount everything up and get everything basically in the enclosure, and then we start going through and doing everything. So, yep, there we go. Electronics and wiring on Thursday. So, let me go here to main view. We haven't had this view in a little while because the printer frame's been kind of in the way. But thank you all for being here. Let's figure out a raid target for this evening. It's 10:30. It's a Tuesday. Jano normally would not be doing... Sorry, I got confused because the first thing I saw was Polymaker. Why is Polymaker still online on a Tuesday night? That's kind of weird. What will Print Busters become? Okay. Well, how about this? Done. We do have Creatix Brit online as well. Pan Fried Nuda, a bunch of other people, but I think we're going to go into Polymaker. So thank you all so much. Let me get a raid started over here for Polymaker. Got Nick on there. And just like that, the raid started. Thank you, everybody, for being here. Thank you to RatRig and Fabrico for getting me this kit so that I can build it on stream and show it off to everybody. We're real close. We're going to be doing all electronic stuff next show on Thursday. So that means hopefully by Saturday, we may see first moves. So let's keep rolling through this. Thank you everybody for being here. Thank you to everybody who subscribed and gave bits. I really do appreciate it. It helps me bring new stuff into the channel and get new capabilities like my Stream Deck and top-down camera and all that good stuff. So thank you all for being here, and I will see you guys on Thursday evening. You guys have a great night, and I'll see you over in Polymakers Polymakers stream. Bye now.